Hello, today we're going to learn a powerful method for solving systems of linear equations. This method is called the elimination method. By the end of this video, you will be able to solve a system of two linear equations with two variables using elimination. Our goal is to find the values of x and y that make both equations true at the same time. Let's look at the system we'll be working with today. We have the first equation, 15x minus 3y equals 126, and the second equation, 2x plus 5y equals 33. The core idea of the elimination method is to manipulate the equations so that when we add them together, one of the variables disappears or is eliminated. This leaves us with a single equation that's easy to solve. So how do we eliminate a variable? We need to make the coefficients of either the x terms or the y terms opposites of each other. Let's look at our system again. We have 15x and 2x, and we have minus 3y and 5y. We need to decide which variable will be easier to eliminate. Let's consider the y terms. We have minus 3y and plus 5y. To make these opposites, we need to find their least common multiple, or LCM. The LCM of 3 and 5 is 15. This means we want to turn one y term into minus 15y and the other into plus 1 5y. This way, when we add them, they will cancel out. To get minus 15y from minus 3y, we need to multiply the entire first equation by 5. To get plus 15y from plus 5y, we need to multiply the entire second equation by 3. Remember, you must multiply every single term in the equation to keep it balanced. Let's do that now. First, let's multiply the first equation by 5. We have 5 times the quantity 15x minus 3y equals 5 times 126. We distribute the 5 to both terms on the left side. 5 times 15x is 75x, and 5 times negative 3y is negative 15y. On the right side, 5 times 126 is 630. This is our new first equation. Now, let's do the same for the second equation, multiplying by 3. We have 3 times the quantity 2x plus 5y equals 3 times 33. Distributing the 3 gives us 3 times 2x is 6x, and 3 times 5y is 15y. On the right, 3 times 33 is 99. So, our new system of equations is 75x minus 15y equals 630, and 6x plus 15y equals 99. Notice that the y terms, minus 15y and plus 1 5y, are now opposites. Now that we have our new system, we can perform the elimination step. We will add the two equations together, term by term. Let's add the x terms first. 75x plus 6x gives us 81x. So we have 81x. Next, we add the y terms. Negative 15y plus 15y is 0. The y terms have been eliminated. This is the key step. The y terms cancel out, leaving us with just x. Finally, we add the constants on the right side. 630 plus 99 is 729. So, our new, simpler equation is 81x equals 729. We have successfully eliminated one variable and are left with a single equation with a single variable, which we can now solve for x. Now we need to solve our new equation for x. Our equation is 81x equals 729. To isolate x, we need to divide both sides of the equation by 81. So we have x equals 729 divided by 81. Let's perform that division. 729 divided by 81 is 9. Therefore, we have found our first solution. X equals 9. We're halfway there. We found the value of x. Now we need to find the value of y. To find y, we can substitute the value of x we just found into either of the original equations. Let's use the second original equation because the numbers are a bit smaller. The second original equation was 2x plus 5y equals 33. We know that x equals 9, so we'll replace x with 9 in this equation. This gives us 2 times 9 plus 5y equals 33. Now, let's simplify and solve for y. 2 times 9 is 18. So we have 18 plus 5y equals 33. To get 5y by itself, we subtract 18 from both sides of the equation. 33 minus 18 is 15, so 5y equals 15. Finally, to find y, we divide both sides by 5. 15 divided by 5 is 3, so y equals 3. We have now found the value of y. Our solution is x equals 9 and y equals 3. It's always a good idea to check your answer to make sure it's correct. We do this by substituting our values for x and y back into both of the original equations. Our proposed solution is x equals 9 and y equals 3. Let's start with the first equation. 15x minus 3y equals 126. We substitute 9 for x and 3 for y. This gives us 15 times 9 minus 3 times 3. 15 times 9 is 135, and 3 times 3 is 9. So we have 135 minus 9. 135 minus 9 is 126. This matches the right side of the equation, so our solution works for the first equation. Now let's check the second equation. 2x plus 5y equals 33. Substituting our values, we get 2 times 9 plus 5 times 3. 2 times 9 is 18, and 5 times 3 is 15, so we have 18 plus 15. 18 plus 15 is 33. This also matches the right side of the equation. Since our solution works for both equations, we know it's correct. Let's quickly recap the steps we took to solve this system using the elimination method. First, we identified the variable we wanted to eliminate. In our case, it was y. Second, we multiplied one or both equations by a number to make the coefficients of that variable opposites. Third, we added the two equations together to eliminate the chosen variable. Fourth, we solved the resulting single variable equation. Fifth, we substituted the value we found back into an original equation to find the other variable. And finally, we checked our solution in both original equations to ensure it was correct. You have now seen how to solve a system of linear equations using the elimination method. With practice, you'll find this to be a very efficient way to solve these types of problems. Great job!